Welcome back, Physics fans, and here we are with our lesson in power and efficiency. This might be the last lesson in this chapter on energy, the power. So that's our definition. That's the power definition right there, the first line. Now think of it as how much work is done in a unit of time. Power is measured in watts. 1 watt is a joule per second. 1 watt is a joule per second. So there's our definition, is a joule per second. So the abbreviation for watt is sometimes done as W, but there's a problem with that for me, and a joule per second. Okay, the formula is power is work over time. That's work over time. But you can see that the unit for watt is W, and you might abbreviate that and might believe that it is actually work when you put that down. So whenever I write down watts, I write down all 4 letters or 5 letters. Okay, so that is the rate at which work is done. Now there's other units of power like horsepower, and 1 horsepower we'll just do as 746 watts. Okay, if you Google it, it'll show up with a lot more digits than that. Okay, I'm not going to do this box yet. I'll come back to that. We'll try doing a calculation right away, but I need to understand when we plug into the wall and charge up our phone, are we plugging into a company called BC Hydro here? Is that a power company or is that an energy company? Are they selling us power or are they selling us energy? Well, if we look at the names of different power companies or energy companies, whatever you want to talk about it, in Ontario it's called Ontario Power. There's Northland Power. There's Nova Scotia Power. There's Saskatchewan Power. So are they selling us power or are they selling us energy? There's BC Hydro, doesn't have energy or power in it. There's Bruce Power in Ontario. There's Bullfrog Power. It sounds like they're selling us power, but if you continue going on down and taking a look, sometimes they have the word energy in there, Suncor Energy. And then it hit these states, and man, there's a lot more words energy. Maybe they sell us different things. When you plug into the wall down there, they get different things coming out. Energy, there's energy here, energy here. So are they an energy company or are they a power company? What are they selling us? Right? Because you take a look at that, these are energy companies in the States, and we go down, energy, but then there's power, Prairie Power. And so they don't know what they're doing by their names, GE Power. So let's take a look at a BC Hydro bill. Maybe we can tell what we're paying for. Okay, and now this is a little old one, but let's take a look at it. They're selling us, this person's got 1,398 kWh, and they're selling it to us at 6.27 cents. 6.27 cents per kWh. And that's how much the person used, and it cost them $87. So they're selling us something that's measured in kWhs. What is a kWh? Well, kW is a kilowatt. But it's not a kilowatt plain. If you take a look at it, there's a dot there. It's kilowatt hour. So what is a kilowatt hour? They're selling it at 6 cents per kilowatt hour. What is a kilowatt hour? Well, a kilowatt is 1,000 watts, and an hour is 3,600 seconds. So this is 3,600,000 watt seconds. So whatever they're selling us is measured in watt seconds. We go back up to our notes. What's a watt second? Well, if we take a look at our notes right here, if we bring the seconds up, multiply both sides by seconds, we get a watt second is equal to a joule. And a joule is energy, not power. So even though all those companies have the word power in it, they're really selling you energy. They're not selling you power. Power is how fast you use the energy. If you use 1,000 joules in a second, or they use 1,000 joules in an hour, it's still 1,000 joules. It'll be a different amount of power because it's faster that you use it. Okay, and so they don't care really how fast you use it. They measure how much you use of it. So question 0, what is a kilowatt hour? 1 kW.h is equal to 3.6 times 10 to the 6 joules. 3,600,000 joules. Why do the companies not just sell it to us in joules? Because this poor guy, he used 1,398, but if we multiplied that by 3,600,000 and wrote that down on the paper, they would freak out. How much energy did you use this month? Oh, I used 4,378,000,000 joules. That's a lot. People freak out when you have a number that big. So they use it in a different unit called kilowatt hours, just so that the numbers become smaller. And if you take a look here, once you reached this maximum amount of 1,398, and then the next amount of power went up to 8 cents, 8.7 cents an hour. So the more you use, it steps up. So the first almost 1,400, they charge you 6 cents, and then any more after that charges you 8 cents, and then if you use more than that, especially if you're a Tesla owner and you're going to be charging up by plugging it at home, it will step up. But I did find this Reddit user posted this month, or no, a couple months ago, that he has an EV, an electric vehicle at home, and he has solar power as well. So he has an inflow from BC Hydro of 780 kilowatt hours, but he has an outflow to the grid. His solar power, put out 900 kilowatt hours to the grid. So his house made more power than he used. So he actually got back from BC Hydro $11. That's pretty cool. So let's do some calculations for power. We'll just do a couple and then we'll let you go on. How much work can 5 horsepower motor do in 10 minutes? And answer in megajoules. Okay, so we're already started with a pretty tough question. Number 1. It's a 5 horsepower motor. And there's a conversion factor. We have to convert that to watts. That's a power. But it's not in the units that we want to throw it into the equation with. So the conversion factor is 700 and, well, let's see what I wrote down on the power sheet here. 746. Do 746. 746 joules is 1 watt. 1 horsepower, sorry. Watts, sorry, is 1 horsepower. There's my conversion factor. So if I multiply that together, 5 times 746 the power that we're using with 5 horsepower is 3,730 watts. Okay, that's the power. And then we do it in 10 minutes. The time is 10 minutes, which is 600 seconds. Okay, now we have a formula. Power is work over time. And now remember, it could also be written down as power is equal to the change in energy over time, because work is the change in energy. But how much work can be done? Work is equal to power times time. That's 3730 watts times the time of 600 seconds. And when I multiply that together, times 600, and I get 2,238,000 joules. 2,238,000, put a comma there, joules, or that is equal to 2.238 megajoules. Okay, we'll see if we could do maybe one more of these. Let's do the girl running up the stairs. "60-kilogram girl." So she's running up the stairs. The height of the stairs is 3.32 meters. And she runs up these stairs. Her mass is 60 kilograms, and she does it in a time of 2.6 seconds. What was her power output? And measure it into different things in watts and in horsepower. Okay, so power is how much work is over time. So we could do work as force times distance. And the force is kind of the force that she's pushing up with, which is against the force of gravity. So the force that she's pushing up with is her own weight, which is mg. And the distance up is 3.32 meters. So we could calculate the work there. But I'm also going to show you a different way. There's 2 different ways to calculate the work. We've learned that. And power is the change in energy over time. So I'm just going to go, everything that's happening here is just keeping the same speed, so there's no change in kinetic energy. But there's a change in potential energy, which is mgh over t. And her mass is 60 times 9.8 times the height, 3.32 meters, all over a time of 2.6 seconds. So her power is 60 times 9.8 times 3.32. That's her energy, 1,952 joules. Divide that by 2.6, and this will be her power in watts, 750.8 watts. And that's our answer for A. And for B, I have to then just divide that by 746, because there's 746 watts in 1 horsepower. Divide that by 746, and we have an output. She's about 1.01 horsepower. Unravel more physics mysteries together by mastering one equation and concept at a time. Join us for the next lesson.